What's going on, guys? In this video I'm going to be presenting an overview of apes, one of my past projects as described in further detail in my project blog, noxa.tumblr.com. Check it out. APE stands for Asteroid Impact Prevention Simulation, and it was a submission to the 2009 Robert H. Mollahan Virtual Reality Modeling Competition. The project was the joint effort of myself and fellow classmate Derek Brown. We were juniors in high school at the time. And now an interesting thing to point out is the competition required us to create a simulation in a modeling language known as VRML. And the particular edition of VRML we had to use was VRML 2.0, which is also known as VRML 97. So that gives you an idea of how old the language was even at the time. Yet the competition still required its usage, so first thing I'm going to do here is open up BS Contact, the only application that I could even find that would run the VRML 2.0 code and still be compatible with a modern operating system. Alright, so the first thing we're going to do here is just take a simple run through of the solar system. And here's our loaded solar system. Here's obviously the sun. We realized that the sun is not this yellow. Our graphic design skills were limited at the time. But as you see, as I twirl around in a circle here, you can see the star pattern isn't uniform. And the interesting thing to point out about how that works, if I go to graphics and wireframe, you see everything in wireframe, obviously, and you see all these blue lines. Well, these blue lines pretty much contain everything that the solar system is in. And if you look over here, you see that there's essentially a massive cube making up the entire world. Meaning world as in all of the VRML, obviously not a planet. That would be ridiculous. And what I actually did is I loaded the texture on every face of the cube to get the illusion that one was actually in space, and I think it worked pretty well. Maybe it's just a failing of the human eye or my own personal vision, but yeah, anyways, let's go back to smooth texturing. Let's go back to our original viewpoint, and let's just take a quick tour of the solar system here. Mercury, Venus, planet Earth, Mars, where we desperately need to go to very soon, Jupiter, and one of the embarrassing ones, Saturn. See, what actually happened with Saturn is somehow our texture for it got botched, so when we presented it, we didn't realize that until the judges noticed it. So that was kind of embarrassing. We still have no idea what happened to Saturn texture to this day. It was probably my fault that it's sort of pinkish, because I think I declared this planet in the code, so I must have for some reason set the RGB values to whatever pink is. I can't remember that off the top of my head. And just the other two outer planets, we did not include Pluto or any of the other labeled dwarf planets. I would have liked to have included some of the asteroid belts, but we did not have enough time for that. Maybe one day, if I decide to do a modern interpretation of this, or maybe you want to check out some other pretty good solar system simulators. They have stuff like that, but that mostly wasn't the purpose of the project. The purpose of the project is dealing with asteroid impacts. And actually, let me go to the Earth viewpoint first. Before I start talking about that, I can show you this cool feature that's actually part of BS Contact. It's the avatar feature, which, granted, is BS Contact's implementation. It's not ours, but it still looks cool. So I can also go in viewpoint tour here, and he can just essentially fly through the entire solar system. It's kind of ridiculous, but awesome at the same time. Okay, that's enough of that. Yeah, if you haven't noticed, the planets in the solar system are actually revolving around the sun. The orbital speeds are scaled and the distances are scaled. I believe I scaled the sizes as well of the planets. So, okay, well, back to the overall point of the project. This is just the basic solar system model. So, well, it was pretty much, it's dealing with the scare of asteroids that we've had in the past. Well, actually, throughout Earth's existence, we've always had scare of asteroids, but now that we have more technology to detect them, we realize that it's actually more of a problem than we realized, that a lot of them come very close to hitting us, and some of them that do hit, like one that hit in Russia in the 20th century, can have nuclear warhead type megaton blast range or blast force. So yeah, that's not so good. So one of the things we wanted to show with this project is a couple of the theorized ways that we could potentially prevent an asteroid from hitting the planet, and try to show that visually through VRML. And so the next thing I'm going to do here is I'm going to open the asteroid impact file. In this file, an asteroid is set on a collision course with the Earth. In terms of aesthetics, we didn't get anything really pleasing, at least in this file. I mean, the asteroid is set on a collision course and is going around the Sun and eventually just going through the Earth, since we couldn't figure out how to include actual collision geometry into VRML. I mean, one of the difficulties was learning VRML, which neither of us had any idea what it even was before the project started, and plus we had limited programming experience, so picking up another language like this was pretty time consuming, and we had small time frame for the project. And another very difficult thing was we could not find a visual IDE or visual application that would let us just, click, drag, sphere, there we go, texture it. No, we had to write all of this with code. So it was very hard, it's very hard to visualize something in 3D just with the code. And if you want to check out the code, you can just check on my blog, noxa.tumblr.com. I'll have all of this uploaded, all the code, instructions on how to run it, the whole shebang. Alright, well, I guess the next thing I can do here is go through some of the models with you and explain the concepts behind them. Stereo image, that's not what I want. Okay, open, browse. Gravity tractor is the first one. Oh my god! Alright, alright, well, the concept of a gravity tractor is just a decently sized satellite, essentially, that would go around the asteroid, and it would slowly push, using gravity, would slowly pull it away, and in an attempt to move it out of the path of the Earth. But granted, this way we would have to detect it pretty early, because we're only going to be able to move it minor distances over decent intervals of time. And another thing is, there are a lot of other gravitational factors, such as the larger planets in the solar system, that will alter the course as well, so it's very difficult to take those factors into account. And okay, I'm going to open up the next one here, and the next one is the kinetic impactor. And the idea of the kinetic impactor is essentially just to shoot materials at the asteroid, just tiny materials, not to actually break the asteroid up into very small pieces, because that's very bad, but just slowly push it away from its course. But unlike the gravity tractor, we could potentially do something like this much sooner. But I mean, then comes the idea: what will you use to push this asteroid away without risking or having a great risk of fragmentation and having all these fragments completely shower the Earth, which would be even worse than one giant asteroid. And the next one is the nuclear warhead, which hitting it directly isn't the greatest idea, because what I mentioned before is fragmentation isn't a great thing. I mean, if you want to do your own research on that, you can. I won't completely lecture during this video. Another idea that some people have had to use nuclear warheads with is to make it explode beside the asteroid in an attempt to maybe break it into pieces, so that those pieces will have a trajectory to go around the planet. And some others have suggested the idea of using a nuclear fusion bomb and melting the asteroid instead of using a fission bomb. And that is essentially all I have to show you with this project. I mean, I hope you enjoyed it somewhat. I mean, if you want the code, just check out noxon.tumblr.com, and everything else is posted on there. See ya.